In LC Trig 1, we're going to look at three things: revision of Pythagoras, trigonometric ratios, and calculator use. I'll try to keep all videos short and snappy so that you can learn 3 or 4 things in each video. So revision of Pythagoras, right angle triangles. Label your right angle. Let's look at a triangle where we have a 2 for the straight sides and x for the hypotenuse. And you guys know that Pythagoras' theorem is that a squared plus b squared is equal to c squared, where c is the diagonal. So 2 squared plus 2 squared is equal to c squared. 4 plus 4 is equal to c squared. And in a question like this, you may be asked to write your answer in surd form, and that's what we're going to introduce here. So c squared is equal to 8. And if you type in the square root of 8 into your calculator, it's going to come out as 2 root 2. Now, why is it 2 root 2? Because the square root of 8, from your surd knowledge, is the square root of 4. Any number inside a square root, we can break into a product. Any two numbers that multiply to give this number. Now, when we're dealing with surds, one of them will have to be a number that we can get the square root of, and 4 we can get the square root of, it's 2. So square root 8 becomes 2 root 2. And this is what's called your surd form. So surd, square root, don't get confused. Let's have a look at another one where we are looking for the diagonal, and then we look at one where we're looking for the straight side. So my right angle, what if I have a 4 and a 6? And you can make these questions up yourself and see will they simplify down into surd form. So we could just type this into a calculator. X is equal to, and when I want you guys getting good at this, you're going to just type 6 squared plus 4 squared, and that is calculator use. And we're going to look at calculator use within this topic. Now, if you didn't use a calculator, say let's just do it the long way. You're going to type that into a calculator, and you're going to get the same answer that you're going to see in a minute. 36 is 6 squared, and 4 squared is 16. So x is equal to the square root of 52. Now, is there any number that divides into 52 that's a square number? Now, 1 we're never going to use because we can't simplify it any further. But the next square number, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. Now, you can see that 4 actually does divide in here. So it divides in 13 times. So the square root of 4 by the square root of 13 is equal to x. So x is equal to 2 root 13. So this x is 2 root 13. And if you type this into your calculator at this point, all modern calculators will give you the answer in surd form. And if you press the relevant button on your calculator, S to D normally, SD will change from surd to decimal. And you read the question carefully and see what form you're being asked for your answer in. Now, I want you guys to test yourself with these 6 questions. Write out the first line of the equation or the substitution method, and then just type it into your calculator. So as you go with these, if you make any mistakes, try and identify what your mistake was. Take note of it and don't make the mistake again. So the first one here, the square root of 21 squared plus 20 squared, it doesn't matter the order, and that's going to give you an answer on your calculator of 29. This one now, this is the first one we've seen where we have the diagonals. So from your previous knowledge, you have to take away the straight side. So in this case, x is equal to, and I should have probably wrote x is equal to here, x is equal to 24. And this is a triangle you're going to see a lot. So when you practice these questions a lot, you'll see the same triangles repeating themselves. Again, we have the diagonal. The square root of 7 squared minus 5 squared is going to come up as 2 root 6. Because 49, 7 squared minus 25 is 24. Square root of 4 by the square root of 6. This one, you should be able to see the answer is root 10 when you start writing it down. 3 squared plus 1 squared is 9 plus 1. So root 10 is equal to x. This one here is really common. 1 squared plus 1 squared is x. So x is equal to root 2. And in this case, x is equal to the square root of 5 squared 25 plus 3 squared 9. X, your calculator will give you root 34. It doesn't simplify. As you can see, none of the squared numbers divide into 34. Hopefully you got all 6 right. If you didn't, just redo them. Try it again. Rewind the video. And you'll get all 6 right the second time. And repetition is the key in maths to get better at any topic. Next part of this lesson, we're going to look at trigonometric ratios. SOHCAHTOA. Why SOHCAHTOA? Because sine is equal to opposite over hypotenuse. Cos is equal to adjacent over hypotenuse. And tan is equal to opposite over adjacent. So let's look at a triangle to see what we mean by that. Now we start with a triangle with one right angle, and this is when we use these trigonometric ratios. We're going to see non-right angle triangles, but not in this lesson. So we have, let's do this 3, 4 triangle. We know the diagonal is 5. So the angle A. We want to label our triangle, and if we stay consistent, we do it the same way all the time. The hypotenuse is always the diagonal, and H and A always touch off the angle, which leaves opposite O, the only third letter being over here. It's not a 0, so maybe just put a little bracket around it or something to show that it's an O for opposite. So what do we have in this case? So we either write down what we have or what we need. We have A and we have O, which are the two straight sides. The two straight sides is always tan, because tan also gives me the slope. So if we say the tan of A is equal to O over A, this O over A, which is 3 over 4 in this case, we have the tan of A is 3 over 4. Now that's just the ratio. How do we get the angle size? We say the inverse tan, and you'll see this button on your calculator, the inverse tan of 3 over 4 is equal to, and this will come out as 36.86989, 36.8, we'll say 869. If we want to round it up, we could say 36.87 or 36.9 or 37 degrees. It depends what you're asked, obviously, how you're going to round it. Now be careful, there is a button on your calculator that says D or G. On most calculators it's D or G. So we're dealing in degrees here. We will be looking at radians within trigonometry. And if your calculator is in radians, it's not going to give you 37 degrees. So be careful that your calculator, if you're looking for degrees, is in degrees, and it will have a little D, E, G at the top of the screen of the calculator where you're typing the information in. So this is how we find an angle. So let's have a look at a couple more of these when we're dealing with sine and we're dealing with cos. So how do we set up a question where we want to use sine? I'm going to write the ratios again. SOH, I'm just going to write SOHCAHTOA. That should help you remember them. So sine is opposite and hypotenuse. So I'll put the angle B up here. Opposite is down the bottom. Give it a number 10. Now the only way I need to make this question accurate is to make sure that the diagonal is actually longer than 10. Let me say it's 20. So sine is equal to opposite over hypotenuse. So we label the triangle. H and A touch off the angle. H and A. We don't have A in this case. We have O. So we have O. We have H. And I always write that down. We have O and H. It'll just show you which two letters are in the ratio that we're using, sine. So we use sine. So the sine of B is equal to 10 over 20, which is equal to 1 over 2. You don't have to simplify it to 1 over 2 because you're typing the inverse into your calculator. The inverse sine of 1 over 2, and that's going to come out at 30 degrees. The sine of 30 is equal to a half. The cos of 60 is equal to a half, or the cos of sine of 60 is equal to root 3 over 2. And the cos of 30 is equal to root 3 over 2. So this is a really common one that you're going to see a lot. So that's how we set up a question using sine. We give ourselves the opposite and the hypotenuse. So let's see, can we do one with cos? And the right angle doesn't have to be, it doesn't have to be this shaped triangle. The right angle could be anywhere. They could turn the triangle kind of sideways. So cos is A and H, you can see that. So we need to, depend on where we put the angle, let's call this the angle C. H and A touch off the angle. So if we want to use cos, we need A. Let's give it a value of 6. And we need H. So let's give H a value of, just the only thing, it has to be longer than 6, or it's not the hypotenuse, which is always the longest side. Let's give it a side of 10. So the cos of C is equal to 6 over 10. When you get really good at them, this stuff can be eliminated. This is just to kind of bring you into the question so you're being consistent all the time. Now we could simplify that to be 3 over 5. And if we type into our calculators the inverse cos of 3 over 5, we're going to get 53.13 degrees, which we'll round off to 53 degrees. Now let's jump back up here and see is there a connection. We got A here to be 37, which means that this would have to be 53 to add up to 90. And we know this diagonal is 5 because we've seen this triangle loads of times. Now let's call this angle the angle B. So what can we say about the cos of B here? I'll do it in red. The cos of B is equal to A, which is 3, over H, which is 5, which is the same ratio we had down here. So you're going to see these angles 53 and 37 coming up quite a lot. So test yourself on the next 3, and then we'll move on to the last part of this lesson. So pause the video now, find the angle A, B and C. Okay, hopefully you've got all these 3 right. What are we going to use when we do 2 straight sides? We're going to use tan. If it helps to write SOHCAHTOA out each time you're doing trig, until you get really good. Tan is equal to O over A. And you can see here, O is 1. So 1 over 4, tan of A is 1 over 4. So the inverse tan of 1 over 4 is equal to 14.03 degrees. This one here, you can see, what have we got? We have H and A touch off the angle, so you can see clearly we're going to use cos. The cos of B is equal to 15 over 22. So the inverse cos of 15 over 22 is equal to 47.01 degrees. And then the last one, you can see C is up the top here. So we have O and we have H. So we're going to use sine. The sine of C is equal to O over H, 12 over 19. So the inverse sine of 12 over 19 is equal to 39.166 or 39.17 degrees. And you can see here with my cos ratio and with my sine ratio, they're both less than 1. They can never be greater than 1. So be really careful with that. The last part of this lesson, we're just going to look at really simple calculator use. You should be able to find that the button on your calculator, D, M, S is what it is on mine, and it's like this, D, M, S. So this is degrees, minutes, and seconds. So if we type into our calculator 64 degrees and 45 seconds, each calculator is different, and you press change or you press second function DMS. In this case, you're going to get 64.75 degrees. And you can see that this is 3/4. If you say 45 minutes is like 3/4 of an hour, this is my 3/4. If you type into your calculator 2.5 degrees, it's like half an hour. So you're converting, this time you're converting from degrees to minutes. You're going to get 2 degrees and 30 minutes and 0 seconds. If you type 2.25 in, this is like 1/4 of an hour. So you're going to get 2 degrees, 15 minutes and 0 seconds. And if you type 25.4 degrees in and mess around with your calculator and change it around, you're going to get 25 degrees. And 4 6s are 24, so you're going to get 24 minutes and 0 seconds. Not a question that comes up a huge amount, but definitely knowledge worth having. So practice these in your book and move on to trigonometry 2.